Hello, grade 3 teachers. Let's have a look at some ways that you can connect the computer sciences into your matter unit. As a quick review, we know that the computer science organizing idea from kindergarten through grade 6 has to do with creativity, design, and computational thinking. We see the learning outcomes take a progression from interpreting instructions to learning how to create instructions to starting to understand those pieces of design and computational thinking and moving towards computer coding and creating computational artifacts. In grade 3, we see creativity and computational thinking come up explicitly in your learning outcome. So it is your job to teach students what computational thinking is. And the great thing about that is there are lots of opportunities to connect that not only into your matter unit, but your other science units and the other teaching that you're doing in all of your subjects and throughout your daily routines. We also see a lot about creativity in the computer science piece of the grade 3, and we are really just looking for students to be using those creative thinking skills to solve problems and look for new ways to do the same things that we're maybe used to doing a different way. So creativity just has to do with thinking of new ways to do something that we may have done a different way, or thinking of a different way to solve a problem, a new path to get somewhere, applying that creative thinking into all of our daily routines and lessons is going to help achieve this outcome as well. Further to creativity, as I just said, looking for different ways to reach the same outcome and connecting this into problem solving. Scientists are problem solvers, and we want to give our students the problem solving skills that they need to be investigators of the world that they're going to live in. The design thinking process isn't going to be taught explicitly in grade 3, though you will be using this and can certainly start to introduce it to your students anytime they're using any pieces of this process throughout their classroom lessons and daily routines as well. And then the computational thinking piece. This is one that you are expected to explicitly teach. So probably you're going to do something in computer science early on in the year, go through this explicitly, talk about the different pieces of computational thinking so that then you can use that language and make reference to this as you're doing it throughout the remainder of your year in both your science classes, all of your other classes, and also just daily routines. So let's jump into the Matter curriculum and look at some specific ways that you can make these connections. When we're talking about objects and their properties or their attributes, we are naturally using computational thinking. So if you have already taught your students those pieces of computational thinking, and then we're looking at something like this, where we're talking about different materials that come from trees, and we may have conversations about what's the same and what's the difference between the trees that different kinds of wood comes from, and maybe we do a bit of an investigation to learn that different types of tree wood are good for different purposes. And then we would land on all trees, of course, create lumber, and then what do we make out of this lumber when we take the trees down? And then we can have, again, conversations about what are we making out of this material. So we are breaking down the objects now that we're discussing and looking for just that one single attribute, which is it made of wood? It doesn't matter what it's used for. It doesn't matter what other properties it might have, like color or shape or size or volume. Right now we are only concerned if the material came from trees. So we have broken that down, abstracted it to its simplest piece. We're just looking at that one attribute, and this is the place where we can make the connection for the students that we are abstracting. And if we are using a model like this where we're discussing and we're generating together, and I've asked students, can you think of some other things that should belong here with the pencil and the paper and the cabin? And they start to tell me other things that come from trees. Now we are moving further into that abstracting piece. We're doing pattern recognition and we're applying it to something else. So computational thinking happening while we're also talking about process materials and the natural materials that they came from. At the bottom, I have this outcome grayed out because it's not something that naturally necessarily connects into computer science. But I would mention that when we're discussing relationships, we see these outcomes about First Nations people's relationships to nature throughout the science curriculum. And when we're talking about someone else's perspective, we are diving into the empathy piece of design thinking. So, empathy is a word that, even though you may not be teaching explicitly design thinking to your students, we could definitely be referencing when we are empathizing and what that means as we're making these outcomes come alive for our students. We can connect into that empathy piece that they will be explicitly learning further on and asked to do when they're using their design thinking. When we get into any science skills and procedures where they're going to be doing investigations or experiments, we are going to have an opportunity to connect into the computer science outcomes that have to do with writing instructions. So we may be doing a physical hands-on investigation to demonstrate that the changes the state of matter. We're going to freeze some water, we're going to melt it, and we're going to see that it stays the same when we do that. And we're having conversations about temperature and learning those scientific knowledge pieces that have to do with matter. We can take it to the next level and connect in computer science simply by asking students to come up with the instructions for the investigation. This is going to hit the skill and procedure from your computer sciences while you're also doing this investigation in your matter unit. Again, we can lead into the computational thinking and talk about how when we're doing this investigation and we're coming up with our steps to make sure that our investigation is sound and it's a good scientific investigation, we're going to be using computational thinking because we're breaking the steps of the investigation down. Even having students just repeat it back is a way to have them interpret those instructions and feed them back to you. You're going to be bridging the gaps from some of those learning outcomes from the lower grades in computer science while you're having students work with those instructions. And then we always have that opportunity when we're working with instructions or rules to add in the algorithm design. So simply by asking students to come up with an algorithm regarding this concept, in this case temperature, we can say, if the temperature goes up, then it is heating. And we may talk about a state change in there as well. But if we're writing that if-then statement, we are doing the algorithm and we're giving the kids those coding skills that will connect into your computer science and also the computer science in the coming upgrades as they start to really dive into block programming and are expected to create some artifacts as well. Again, just some more connections to how the skills and procedures, and we're learning some really specific things about matter and materials. And if we can connect into, involve students in coming up with the set of instructions, repeating back the set of instructions, perhaps we may look at, is there two different sets of instructions for this task? And will it change our investigation if we follow this set or this set? So those kind of conversations are going to be, again, involving abstraction, thinking about breaking this process down into its steps. You're going to hit the computer science outcomes about writing sets of instructions. In particular, if we're working in groups, then we're also doing this collaboration piece where we're writing a set of instructions. Any type of task, activity, investigation, experiment that you have done with the class in, say, your matter unit, you can always take that and extend it into the next level of that algorithm design. So we just did this experiment, we just did this investigation. Can you come up with a set of instructions that you would give to another human or a machine, and it would help them do the investigation that we just did? And by asking students to do that, we don't even have to have any kind of technology involved. This could be just saying those instructions out loud or writing them down in regular language on paper. If it always has the same shape and volume, then it is a solid. We're framing those rules in the form of an algorithm and making the connection between the matter topic as well as the computer sciences. Again, having students come up with instructions about safety. There is a safety specific knowledge cusp in one of the lower computer science grades. So again, you would be doing that gap bridging when you're covering this safety item in your matter unit. And again, opportunities to get into that instruction writing, working with others, taking it to the next level. After we've done this activity in learning, could you look at a way to tell a machine or another human how to do this? What would those instructions look like? Looking at the similarities and differences between freezing and boiling in relation to states of matter. Again, just making a quick connection into pattern recognition. We may start to talk about water because that's an easy place, something that students have a definite physical immediate reference for. But then when we start to compare, well, this boils at a lower temperature and this boils at a much higher temperature, and we're having those conversations, we're taking what we know about water, applying it to other substances, and we are working in pattern recognition and pattern abstraction. And these are the places where we would actually say this to the students. Hey kids, I think we're doing some computational thinking here. What step of the computational thinking process do you think we just did when we had this discussion? So just bringing that conversation into your other teaching is going to just keep ingraining and really help embed that learning and help your students understand that computational thinking isn't something that only applies to computers or writing computer programs or robots, that computational thinking is really about problem solving, and we do it all of the time in our daily lives, and it can help us solve problems and think of new ways to do things. I have a Scratchtivity that has been created about doing a water cycle that would be appropriate for your grade 3 students, especially if they're already familiar, if you're using it with your class. So this is going to take the water cycle, which of course is a skill and procedure here on the matter topic, and really bring computer sciences in by having students work with some block programming in the Scratch language to just create a little animation that shows what they know about the water cycle. So again, we're going to hit these skills and procedures from the computer sciences. Definitely we're working on creating a set of instructions. This is getting up into making sure that we're really, really connecting into coding. So even though the grade 3 computer science doesn't really talk about coding, we're talking about computational thinking. We know the end goal in grades 4, 5, and 6 is to be using a block-based language, creating computational artifacts. We know for many years now that teaching kids coding as early on as possible is going to give them a leg up in the job world. So even though computer sciences is new within your curriculum, it's very probable that you've been trying to embed some coding, and we don't want to lose touch with that now that the computer sciences has come in and they are giving us some outcomes and things that we want to explicitly cover. Let's not lose touch. I think it's always good to make those connections to coding. Get your kids into a block-based language, use code.org or Scratch or CS First, and have them get hands-on with the block-based coding as early on. So this is, as I say, an activity that grade 3s can easily complete. I have a set of scratch cards that show all of the blocks that they need to put together on the specific sprites. There's a template in my Scratch Studio that has all of the sprites and everything in there ready to go to just start building that code. Even if you've never done Scratch with your students, once they have an account, they can definitely follow through with these lessons. So that is one way. I added a couple little icons in here just beside a couple of the other skills and procedures. I mentioned about empathy earlier, so it might feel like a bit of a stretch to be applying empathy into nature. But I think that when we're trying to teach students what empathy is, any connections that we can make to it are going to really help us show students what that means. So when we're talking about respecting water, maybe we're having conversations about how would the animals feel if their water is dirty. And so now we're empathizing, we're applying and putting ourselves into another position, which really is what empathy is. And being able to take what we know about changes of state of water, say here in Alberta, what do you think it's like somewhere closer to the equator? We're going to apply that pattern abstraction and we're taking what we know and applying it out. And then this project is really going to dive in, as I say explicitly, into doing some coding. So these are the links and the QR codes that will get you to this project. The cards, as I say, it's a Google Slides. It's going to make a copy for you when you follow that link or enter that bit.ly, and you'll have your own copy that you can share out with the students, edit if you see fit. And then the other link takes you directly to the template in Scratch. There's a big green remix button when you get to the template that you would want to hit to play around with this, or that's what your students are going to hit to use that template. It's going to take it with all of the sprites and backgrounds there, make a copy, and it'll be ready for whoever clicks that green remix button to use. And last but certainly not least, when we're covering these skills and procedures here, and again, we're having discussions or we're safely performing experiments, we will have these opportunities to connect in the computational thinking that we're doing. So if we're talking about those types of changes that are reversible or irreversible, we can, start to say, well, we're looking at just the specific attribute. It can be cooked, for example. Well, what are some other things that can be cooked? Once something's cooked, can we uncook it? No, we can't. So then we determine that is an irreversible change. Oh, cooking is an irreversible change. Can you think of anything else that would be an irreversible change? And then maybe we come up with stretching. And we could have conversations about some things are meant to be stretched and they go back and other things won't go back. So not all materials have the same quality as far as elasticity, etc. So when we're having those conversations, again, every time we ask them to think about a specific attribute, we are simplifying, abstracting, decomposing that thing down into the only small part that we care about it. We're simplifying what we're looking at and breaking it down into something that's easy to work with. And then when we're making those connections to other things, we ask students, what's something else that can't be reversed? We're connecting, pattern recognizing, and then applying those patterns into other areas. So when you're doing this with the students, again, after this activity, after the discussion, we can have that secondary discussion about, hey kids, do you think we used our computational thinking skills today? And we can break that down, reference it, and again, we're just embedding that learning into what we are doing. So those are some ways that you can connect your computer sciences into your matter unit. You can probably find some ways to connect these ideas into other areas of your teaching too. Thank you for watching.